Okay. Next, look, all these things I am making it for you such that when you go through, it will be very easy for you to this thing, even without looking into the book you can make it of your own, right. So, now next is x3, this one, right. So, in this case if you look in the block diagram, that x3 is equal to 2 pi t12 upon s, 2 pi t12 upon s into, this is actually x1. So, this is x1 and this is x2. So, into x1 minus x2, right. So, it is plus x1, it is minus x2, x1 minus x2, right. That means s x3 is equal to 2 pi t12 x1 minus x2. That means x3 dot is equal to 2 pi t12, I am making the bracket, 2 pi t12 your x1 minus 2 pi t12 into x2. So, this is your what you call x3 dot. So, if you, this is the third equation, if you look at the third equation, x3 dot is equal to 2 pi t1 to x1 minus 2 pi t1 to x2, rest of the your what you call elements are 0, right. This is the third equation, and similarly for the third row, both your, this is B matrix, this is gamma matrix, third row this is 0, this is also 0, right, because no u or delta PL is involved there. Next is your x4 dot. So, this is my x4, this is my x4. So, x4 is equal to actually x6 upon 1 plus STT1, right. So, this is x4. So, I am making it this way, they look, x4 is equal to your x6 divided by 1 plus STT1, right. That means x4 plus sx4 into tt1 is equal to x6. That means this is actually x4 dot, therefore, x4 dot is equal to minus x4 x4 dot tt1 is equal to minus x4 plus x6, right. That means here I am making it, that means x4 dot is equal to your minus 1 upon tt1 x4 plus 1 upon tt1 x6. So, here also no u involved, this is your x4 dot, here also no u involved, no delta PL is involved, only these two elements will be there in that A matrix, right. So, if you see the x4 dot, it is minus 1 upon tt1 x4 plus 1 upon tt1 x6. It is look minus, all are 0, first 3, minus 1 upon tt1, this into x4, it fifth one is not there, then 1 upon tt1 your x6, right, 0. And similarly on the fourth row, because no u, no delta PL is there, so here it is 0 0, here also it is 0 0, right. Next you consider that x5, right, that is your this one, x5, this one. So, similarly you can write x5 is equal to x7 upon 1 plus STT2. That means we can write x5 is equal to x7 divided by 1 plus STT2, then cross multiply. So, it will be x5 plus sx5 tt2 is equal to x7. That means, this is your x5 dot is equal to, let me make tt2 here also, x5 dot tt2 is equal to minus x5 plus x7, right. Therefore, x5 dot is equal to minus 1 upon tt2 x5 plus 1 upon tt2 x7, right. So, here also no u, no delta PL is involved, only A matrix has to be filled up, fifth element and the seventh one, that is the, if you look at the fifth row. So, first 4 are 0, it is minus 1 upon tt2 x5 minus 1 upon tt2 x5, this one minus 1 upon tt2 x5 plus sixth element is 0, 1 upon tt2 x7. So, 1 upon tt2 x7, this is your fifth row, and here also fifth one is, here it is 0 0 because no u is involved, and here also it is 0 0 because no disturbance thing is involved, right. So, this is your x5. Then if you come to x6, this one if you come, right, then just it will be like this. Rather than writing on the notebook, you are making note of this thing, I thought I will make it here such that it will be easy for you to understand, right. So, now x6 will be, look, this u1 will be there, it is plus minus, this x1 is coming here. So, this is your x1. So, basically it will be x6 is equal to u1 minus x1 upon r1 into 1 upon 1 plus s tg1, right. That means, we can write that x6 is equal to, u1 minus your x1 upon r1 into your 1 upon 1 plus s tg1, right. So, if you go for cross multiplication, it will be x6 plus your s x6 into tg1, this one writing first, minus x1 upon r1 plus u1, right. That means, we can write s x6 is x6 dot, right, tg1 is equal to this one writing first, minus x1 by r1 minus this one we are writing first, x6 plus u1. Therefore, your x6 dot is equal to minus x1 upon r1 tg1 minus 1 upon tg1 plus 1 upon minus 1 upon tg1 x6, then 1 upon tg1 u1, right. So, this is the equation. When I am making all sort of things, by chance this is a recording thing, right, and continuously you have to move, right. If I make any mistake anywhere, if you observe throughout this course, because many places I have tried to derive, hoping that things are okay, but if you see that any point or anything I have missed or something written incorrectly, but later hopefully it has been corrected, right, but still you point out to me, hopefully things are okay, right. So, because in the nobody is sitting in front of me, then they can rectify, sir, on the blackboard when you write, if we miss any term, immediately they point out, sir, you have missed that term, right, but here nobody is there in front of me, right. So, anyway, so this x6 dot will be your, then this if you come to the sixth element, then it will be a61 will be minus 1 upon r1 tg1. So, if you come to that it is x1, so minus 1 upon r1 tg1, then you are directly come to the sixth element of that sixth row, right, because rest in between all that your what you call 62, 63, 64, 65, a63, 64, your a61, a62, a63, a64, a65 all are zeros. So, all are actually zeros, right, these are zeros. Then sixth element is coming your minus 1 upon tg1, here minus 1 upon tg1 into x6, and in the u, that sixth element 1 upon tg1 u1 is there. So, we will go to the B matrix, that sixth row, B matrix, this is the sixth row. So, here it is 1 upon tg1, it is 0, no delta PL is involved here. So, it is 0, but it is 1 upon tg1, right. So, similarly if you write your last equation, that is your x7, right. If you write the last equation x7, look at here, last equation if you write here x7. So, this is actually your x2, this is x2. So, it is u2 minus x2 upon r2 into 1 upon 1 plus stg2 is equal to x7. So, this one we can write that your x7 is equal to, from here only, right, it is u2 minus your x2 upon r2 into your 1 upon 1 plus s tg2. Go for a cross multiplication, it will be then x7 plus s x7, then tg2, writing this one first minus x2 upon r2, then we are writing u2, right, or sx7 is equal to your x7 dot, then tg2 is equal to this one writing first minus x2 upon r2, then after that this minus x7 this one and plus u2, right, or x7 dot is equal to minus x2 upon r2 tg2 minus 1 upon tg2 x7 plus 1 upon tg2 u2, right. This is your x7 dot. So, u2 is involved here, u2 is involved here, other things is only A72 and your what you call A77, these two elements are there in the A matrix, right. So, A72 is minus 1 upon R2 Tg2 and then this one A77 minus 1 upon Tg2, and last one is that it is your it is 1 upon Tg2 u2 is there. So, here it is 1 upon Tg2 u2 is there, right. Therefore, it is 0 first one, then 1 upon Tg2 u2, and here it is 0 0, and this is delta PL1 delta PL2 u1 u2, right. So, this is equation 31. Equation 31 means all together this one, this is left hand side, it is x dot, this matrix is Ax, right, and this one your Bu, and this is gamma p. If you observe one thing, you will see because of this tie line power flow, this one diagonal element is actually 0, but rest all are your what you call have a negative sign, at least in the diagonal, and because of this tie line, that this one element is here is 0. So, this is a 7 into 7 matrix, right, and this is your 7 into 2 B matrix, and this is gamma matrix. So, this is your 7 into 2 again. So, this is what your what you call that what is that you can write now x dot is equal to x plus bu plus gamma p. Now, that means this equation is written as x dot is equal to x plus bu plus gamma p in this form. This is equation 32, where u is equal to u1 u2 and p is the disturbance vector delta PL1 upon delta PL2, where A is a 7 into 7 matrix I told you, B and gamma are 7 into 2 matrices, x, u and p are the state, control and disturbance vector, right. State variable whatever we have chosen, you can alternate also or you can interchange also this way that way, no problem, but you will get the same result, right. So, suppose if we want this equation is equal to x dot is equal to x plus bu plus gamma p, suppose it is uncontrolled, suppose u is 0, u is 0 means actually is equal to u1 is equal to 0, u2 is equal to 0, it is uncontrolled mode. Therefore, this equation x dot is equal to x plus bu plus gamma p, right, as u is 0, that means this equation can be written as x dot is equal to say uncontrolled mode plus gamma p, it is uncontrolled mode when u is equal to 0. Now, at steady state I told you, suppose steady state means suppose your x I am making it as a transpose, say x dash x transpose your x1, x2, x3, x4, x5, x6 and x7, right. Now, this is transpose. So, it is steady state, actually a steady state if you put this transpose, this all will be x1 SS, x2 SS, x3 SS, all the steady state value x4 SS. This we are also we have seen for single area x6 SS and x7 SS, right. So, these are all the your what you call the steady state value. So, when all these things, all these state variable reaches to a steady state, the derivative is 0, right. So, that means that means if you take if I put like this rather than transpose now, suppose if I make it like this, x SS is equal to your x1 SS, x2 SS, x3 SS, SS means steady state, right, x4 SS, x5 SS, x6 SS, x6 SS and x7 SS, right. These are the thing x steady state. If you make their dot, suppose xs SS, then if you make xs dot, then x1 steady state dot, x dot all the steady state dot. So, at steady state when all the state variables I reach to the steady state means it will be 0 0 0 0 0 0 0, right, all 7 zeros are there. So, it will reach to the steady state. Therefore, in this equation when you put x is equal to your xss, that means your writing on the next page, that means your xss dot is equal to ss plus gamma p. That means my this one actually this is 0 xss steady state. I told you that all the steady state values this will be actually is equal to 0, right. So, all x s dot will be 0. Therefore, this 0 is equal to A x s s plus gamma p. That means, A x s s is equal to minus gamma p multiplied both side by A inverse, that means x s s is minus A inverse gamma p, right. Only thing is that A inverse has to exist, but for this kind of system let me tell you A inverse exists. That means, you know A inverse, it is a 7 into 7 matrix, gamma matrix is also known to you, right, and because and P load disturbance is also known to you, PL1, PL2, everything is known to you, parameters are known to you, A matrix parameters are known to you. That means, this one actually it will become a your what you call 7 into 1, right. So, in that case your what you call this, all the steady state values x1 ss, x2 ss, everything you will get. I mean all the 7 state variables whatever I have shown, right, all this your this thing your steady state values you will get. So, all these steady, but at steady state this is actually x3 dot, this is steady state values of all x1 ss, x2 ss, all you will get, and that means the steady state values of all the values you will get, all the 7 state variables. In MATLAB you can easily verify if you know the MATLAB, take some parameter and just check, you will get all these values, right. So, that is why your what you call that this is easy way to find out the steady state value. Of course, that your A inverse has to exist, right, it has to exist, then only it is possible, otherwise it is not possible, right. So, anyway, so this will be a 7 into 7, that means all the values whatever we will get, first one will become x s 1 s s, second one x 2 s s up to x 7 s s, whatever we will get this side, all the steady state values you will get, you can easily verify in the MATLAB also, right. So, that is why this is your what you told that about x dot is equal to x plus bu plus gamma p. Now we have to go for this, that is how I told you how to go for steady state analysis for all the variables. Now, mathematically we will see also from here, same as before we will proceed that the steady state frequency deviation is, but there here you are getting your what you call the steady state value whatever you are getting here directly all the numerical values, but we have to obtain some mathematical expression for that. So, that means at the steady state actually even it is a two area system, a steady state that your delta f1 actually is equal to delta f2 is equal to delta fss, and we are considering this is uncontrolled mode, that is I told you u1 is equal to u2 is equal to 0, uncontrolled mode written here in red ink, right. So, this delta f1 is equal to delta f2 is equal to delta fss, this is a steady state error. Steady state both the area steady state error is same. Therefore, for power balance equation that what you call that earlier this equation for power balance equation, now look at that at steady state it will be delta Pg1 ss, load disturbance will be there as it will be delta p ti 1 to ss, right. From our general knowledge only we are trying to make it as steady state. I told you that any derivative of any state variable will become 0. So, at ddt of delta of f1 will be 0 because it has reached to the steady state, and this will be actually del d1 into delta f1 ss, right. At steady state this term will vanish because its derivative will become 0. That means, this equation delta Pg1 ss, instead of now Pg1 we are making ss the steady state, delta Pg1 ss minus delta p ti 1 to ss minus delta PL1 is equal to d1 into delta fss, right. This is actually coming from equation 27. Similarly, your this thing only this part will be vanished, right. So, similarly your what you call similarly for the area 2 if you write, I told you that area 2 in the case of area 2 equation will remain same, it will be I did not write that one, but understandable, it will be delta Pg2 minus delta PL2 minus it will be delta p ti 2 1, hence it will be minus A12 into delta p ti 1 2 is equal to it will be 2 H2 upon F0 into ddt of delta F2 plus d2 into delta F2 for the area 2, understandable, and again this part will be vanished for the area 2, and in that case it will become delta Pg2 ss minus delta p ti 2 1 ss actually is equal to minus A12 delta p ti 1 2 ss, steady state error. Here also for area 2 I told you how I will make it, is minus delta PL2 is equal to d2 into delta fss, this is actually equation 35, right. And we also know from isolated system same philosophy will be applied here, that delta Pg1 steady state actually minus delta FSS upon R1. In the case of your isolated case, we have seen that delta PGSS actually is equal to minus delta FSS upon R, but here 2 area system it is. So, for area 1, delta Pg1SS will be minus delta FSS upon R1 and delta Pg2SS is equal to minus delta FSS upon R2. This is equation 36, this is equation 37. Now, this delta Pg1SS and delta Pg2SS you substitute here. That means this equation will be function of delta FSS and delta P12SS. Similarly, delta Pg2SS is equal to minus delta FSS upon R2. This you substitute here. Here you will substitute. Then this equation will become function of your what you call delta P your this it is in the in terms of delta P12SS and delta FSS. So, this equation also in terms of delta FSS and delta P12SS. This equation also will become in terms of your delta FSS and delta P12SS. Then solve these two equations, right. So, I am not putting and showing it here, it is understandable. Delta Pg1SS you put it here, right, and make one equation, and here also delta Pg2SS you make it here, make this another equation and solve this, right. So, if you solve it, because it is a linear equation solving, so no need to do it, you will be able to do it, right. So, if you do so and solve it, then that is why I am writing solving equation 34, 35, 36 and 37 the way I told you, you will get delta FSS is equal to A12 delta PL1 minus delta PL2, right, divided by D2 plus 1 upon R2 minus A12 into D1 plus 1 upon R1. This is equation 38. That means, at steady state uncontrolled mode 2 area system, actually frequency deviation of both the areas are same, right. It is not delta F1SS or delta F2SS, it will be same, and type and delta P type 1 to SS, after solving those two equations you will get D1 plus 1 upon R1 into delta PL2 minus D2 plus 1 upon R2 into delta PL1 divided by D2 plus 1 upon R2 minus A1 to D1 plus 1 upon R1. So, numerators are different, but denominator both cases it is same, D2 plus 1 upon R2 minus A1 to D1 plus 1 upon R1. This is equation 13. That means, uncontrolled mode at least these expressions are known to us, right, and this expression is known to us means that is your delta Pg1SS is equal to minus del FSS upon R1. So, you know the del FSS, so you can easily find out delta Pg1 and delta Pg1SS and delta Pg2SS, but this is the expression, right. You can solve it, you please solve it of your own and just get it, this is a simple thing, right. Now, once this is done, delta FSS and delta your P type 1 to SS, and just before moving further from this equation only, suppose in area 1 disturbance is only there in area 1, this disturbance is there in area 1, and area 2 suppose disturbance delta P2 is equal to 0, there is no disturbance in the area 1. So, in that case this equation will become delta FSS is equal to A1 to delta PL1 divided by D2 plus 1 upon R2 minus A1 to D1 plus 1 upon R1. Similarly, in the type power equation, if your what you call delta PL1 is your delta PL2 is equal to 0, if delta PL2 is equal to 0 in the type power equation, then it will be delta P type 1 to steady state is equal to, right, delta PL2 is 0. So, this term will not be there, it is minus your D2 plus 1 upon R2 delta PL1 divided by same thing, same denominator, minus A1 to D1 plus 1 upon R1, right. So, this is your what you call expression for this one. Now, we know for example, everything we are talking, this is in hertz, this is actually in hertz and this is in per unit megawatt, right. This is not in per unit, this is in hertz and this is in per unit megawatt. Now, if we know, we have seen no A12 is equal to minus PR1 upon PR2, right. That means, if we assume, let assume area capacity ratio PR1 PR2 is equal to 1, their PR1 is equal to PR2, that is they are same, that means A12 is equal to minus 1. So, if we put here A12 is equal to minus 1, here you put in this, here also, here you put minus 1. If you do so, then you will get delta F steady state is equal to minus delta PL1 divided by D2 plus 1 upon R2, and A12 is minus 1, it will be then plus, right. So, it will be plus D1 plus 1 upon R1. Similarly, delta P tie 1 to SS, here only it will be minus 1, so it will be plus, right. Therefore, delta P tie 1 to steady state is equal to your minus D2 plus 1 upon R2, right, then into delta PL1 divided by D2 plus 1 upon R2 plus your D1 plus 1 upon R1, right. Now, suppose you assume load is insensitive to the changes in frequency, that means just for the sake of clarification, some understanding, say D1 is equal to D2 is equal to 0, say load is insensitive to the changes in frequency. If D1 is equal to D2 is equal to your 0, right, then your delta F SS will be minus delta PL1, as D1 D2 is equal to 0, it will be 1 upon R1 plus 1 upon R2, right. Similarly, here also if D2 is 0, D1 D2 both are 0, then delta P tie 1 to S, delta P tie 1 to steady state, D2 here D1 D2 0, it will be minus delta PL1 divided by R2, and here it will be 1 upon R2 plus 1 upon R1. This is delta P tie 1 to SS, and this is delta FSS, right. So, if you take say R1 is equal to R2 is equal to R, same value if you take, right. So, that means delta FSS will become minus 2 delta PL1 minus your R into delta PL1, right, divided by 2, right. You take R1 is equal to R2 is equal to R. So, it will be your minus R into delta PL1 upon 2. Similarly, for tie power, if you take they are same, then delta P tie 1 to SS steady state is equal to, it is minus delta PL1 divided by R, we have taken both are same, it will be 2 by R, right. That means minus delta PL1 upon R, right, into R by 2. So, it will be minus delta PL1 by 2, right. That means, when D1 D2 is equal to 0 and both are your what you call R1 is equal to R2 is equal to R. So, if we write separately, then what will happen, that steady state error delta FSS is equal to, you will get here one minus sign is here, right. Here it is minus R into delta PL1 upon 2, and for tie line power delta P tie 1 to steady state is equal to minus delta PL1 upon 2. This is actually, this will be very helpful for the numerical point of view. So, what we have done is condition here, what we have taken? We have taken D1 is equal to D2 is equal to 0. We have taken R1 is equal to R2 is equal to R. In addition to that, PR1 is equal to PR2, such that A12 is equal to minus 1, right. Now, for example, if delta PL1 is equal to say 0.01, right, and R is equal to 2.4 hertz per unit megawatt, right. Therefore, your steady state value delta FSS will be minus 2.4 by 2 into 0.01, right. So, you will get it is your minus is equal to minus 1.2 into 0.01. So, minus 0.012 hertz, right. So, this is the steady state value, and for tie power, making it here for tie power, it will be delta p ti 1 to steady state is equal to minus 0.01 by 2 per unit megawatt is equal to minus 0.005 per unit megawatt. So, this will be very helpful for your numerical point of view. Just have some your this thing, and if you consider that d value I mean d1 d2 is equal to 1 upon your what you call Kp is 120 1 upon Kp. So, 1 upon 120, if you take d1 is equal to d2 is equal to 1 upon Kp and Kp is 120 means 1 upon 120, then you will get this value is slightly less, it will become minus 0.0117 Hz if I recall correctly, right. But this is a good approximation, I mean very close actually, and this is also. Thank you very much.